What's the formula for area of a triangle? 1/2 base times height. And that works wonderful so long as I have the base and the height. But sometimes we don't. So let's look at what we can do instead. Take a look at the triangle to the left. By dropping that perpendicular height, I've created a smaller right triangle. So now, using angle A, let's write down sine of A in terms of the smaller right triangle. Side H is opposite and side C is hypotenuse. So I know that sine of A, based on the smaller right triangle, is H divided by C, the ratio of the height to side C. Now, let's go ahead and solve this equation for H, because do you see what I'm doing? I'm going to get an equivalent statement for the height based off an angle. Multiplying by C on both sides, I now have that the height is also equivalent to side C times sine of angle A. Let's substitute that into the area formula. It of course doesn't matter which vertex I drop the height from. So if I wanted to drop the height from vertex A, I can go ahead and repeat this process and come up with an equivalent formula. So you see I've written all three based on which vertex I might be working from. But most importantly, I want us to remember this. Let's talk about this first one that we went ahead and derived. Area is equal to 1/2 BC sine of A. Well, side B is this entire length, side C is this entire length, and what about sine of A? We're talking about angle A. Well, angle A happens to be the included angle between the other two sides. So that's basically what I'll be remembering. I'm not going to try and memorize ABC. I'm going to remember 1/2 side sine of the included angle. Let's practice this. Looking at this figure, I know angle A measures 31 degrees. So I want to work from angle A. The two sides that form that angle are measured 5 miles and 10 miles. So when I evaluate the area of this triangle, it'll be 1/2 side times side, meaning 10 times 5, times the sine of the included angle, so times sine of 31 degrees. Plugging that into the calculator, we now know that the area is approximately 12.9 square miles. Don't forget that square on miles because area is always squared, units squared. Now, using our equivalent area formulas, we're going to derive the law of sines. We take our formula and we multiply all parts by 2. Next, this still looks like I can clean it up a little bit. So why don't we go ahead and divide by all three sides, side A, side B, and side C, the product of the three sides. Doing so, we see that we can go ahead and divide out the B and C from the first fraction, leaving sine of A over side A, the A and C from the second fraction, leaving sine of B over side B, and likewise sine of C over side C. So essentially, law of sines tells us that in a triangle, the sine of the angle divided by the side opposite is going to be proportional to the side of another angle and its opposite side, and so on. This allows us to solve for missing measures within a triangle. Let's see how it works. So in our example, we're given triangle PQR and some measures within that triangle. Go ahead and label those. Next, we're asked to find the length of side RQ. So let's use law of sines. What we always want to do is look for an angle whose opposite side I also happen to know the length of. So here I know the 40 and I know the angle 39. That's how I'll set up my fraction. So sine of 39 degrees divided by 40 is equal to sine of P divided by its opposite side, which is the one we want to know, RQ. But wait a second, I don't know angle P. Well, yes, we kind of do, because if you remember, the angles of a triangle always add up to 180, so I can find that third angle P. Now that I know that the measure of angle P is 109 degrees, I can set up my second fraction, sine of 109, divided by the unknown side, x. Now let's solve that proportion. Quick reminder. In any given proportion, you know, where one fraction is equal to another fraction, the product of the diagonals are equal as well. So I'll go ahead and multiply x times sine of 39 degrees and set it equal to 40 times sine of 109 degrees. Doesn't matter which one you write first. From here, to solve for x, all we need to do is divide out sine of 39 degrees. Really get it in your head that sine of 39 degrees is a value. So I divide out that entire value. Then I can plug it into a calculator and get my approximated answer. So we now know x is approximately 60.1 centimeters, or more importantly, side RQ is approximately 60.1 centimeters. Go ahead, try the next problem. Sketch it, write a proportion, solve. Measure of KL is approximately 31 centimeters.
Now let's try using law of sines to find a missing angle. Looking at this next one, we have triangle RST and we want to find the measure of angle S. I know the measure of angle R and the side opposite, so sine of 110 degrees divided by 9. So to find the measure of angle S, it'd be sine of angle S divided by the side opposite. But wait, I don't know the side opposite. So I'm going to have to go for angle T first, because I know the side opposite of angle T. After I cross multiply, I divided by 9. So now I have sine T equals 7 sine of 110 degrees divided by 9. How am I going to get rid of the sine in front of my angle T? What's the inverse of sine? Arc sine. So arc sine undoes my sine. Now I have angle T equals arc sine of 7 sine 110 degrees divided by 9. Let's carefully plug this into our calculator, making sure we're in degree mode. So the measure of angle T is 47 degrees. Am I done? No, I wanted to find the measure of angle S. Do I need to use law of sines again? No, I have two angles. Let's just subtract from 180. So we get 23 degrees. Pause and try the next one. The measure of angle P is approximately 68 degrees.
So what happens when I'm working with a non-right triangle and I don't know an angle and a side opposite? Law of sines can't be used. Then we have law of cosines. It's a bit more involved. Let's take a look. Working from side A, I know I can say a squared equals b squared plus c squared, but then minus 2bc cosine of A. Interesting. Let's try that one more time. A squared equals b squared plus c squared minus 2bc cosine of A. So here's a couple of things that I do to remember this. If I'm working from side A, I know that I'll have angle A for cosine. Then of course, all I have to do is square both of the other two sides, subtract 2 times the other two sides, cosine of angle A. Fill out the pattern working from b squared and then from c squared. Did you get it? Let's just emphasize something here. If you had b squared equals c squared plus a squared minus 2ca cosine of b, would that matter? No, because both addition and multiplication are commutative. So when we work with this formula, we don't have to worry about which order those are in, so long as we have the correct sides.
Take a look at this next example. First thing I did was draw a sketch. I know two sides and the included angle. So can I use law of sines? No. So law of cosines it is. Let's label the sides. I chose to name the 40-degree angle A. So it looks like I'm going to be looking for side A. Set up your law of cosine. Whew, we almost have it. Do I want to solve for a squared or A? A. So let's square root that and then plug it into the calculator. So it looks like that third side is approximately 2.3 miles. In this next example, we want to solve for a measure of angle B. So that means we want to work from side B, which is 12. Let me get you started. 12 squared equals Now that we have the setup, let's do some simplification before we solve for cosine B. $144 equals 9 cosine B. Did you do what I just did? That is so wrong! Can I do 89 minus 80 cosine B? No, Those aren't like terms. So let me subtract that 89 first, then divide by that negative 80 in front of my cosine b. Arc cosine of 55 divided by negative 80 is about 133.4 degrees for the measure of angle B. In this last example, we're going after measure of angle B again. If I use law of cosine, I would work from that side B, 6.2, but when I set up law of cosine, what happens? I'm missing my measure of angle B and I don't have side A. So I better go after A first and then use that to go after B. So why didn't that work this time? If I look back at my other two examples, in the first example, I had two sides and the included angle. And in the second example, I had all three sides. So in my example, angle A is the one included between the two sides that I know. So I have to go after side A. The measure of side length A is about 5.55775. And because we're in the middle of a problem, it's best not to round too much. So I could go back up here and plug in A. But wait, don't do that. Look at what we have in our triangle. I have an angle and the side opposite. I'm looking for angle B and I know the side opposite. What can I use? Law of sine. After we set up law of sine, you can solve. So the measure of angle B is about 52 degrees. So to recap, law of sines is way less involved. So anytime we have an angle and the side opposite, we're gonna use law of sine. When we don't, we'll have to use law of cosines. But as soon as we can go back to law of sines, we will. Just did.